Welcome back. Today I'm going to be going over this SAT System of Equations question. And once again, thanks to Anico.ai for providing this question in their free resources tab. But before I go on and explain this problem, please give it a try yourself. Okay, so here we're given a system of equations, right? And it says for any real number r, which of these four choices gives a point that lies on the graph of both equations? So this is different from other system of equation problems. It's because they're not asking you to find like a intersection point, right? They're asking you to find a kind of an you could think of it as a point with some parameters like an r, right? So that r in this case would function as a variable, and if you plug that in to the x and y, well, that should give you a point that lies on the graph of both equations. But before we even get to the answer choices, let's just look at our system here, right? So if we use Desmos here for a second and type in each of these, right? What you'll actually realize is that these equations, right? They're the same exact line, right? As you can see, they're the same exact line. So what does that mean? Well, remember, right? If they're the same exact line, well, that means that this system here has an infinite number of solutions, right? There's infinitely many solutions. So what value does that have in this problem? Well, because there are infinitely many solutions to the system, right? If you're looking for a point that lies on the graph of both equations, well, two things, right? First, we're just looking for a point that lies on the graph of both of them, right? Because they're the same line. So essentially, we're just looking for a point that lies on the graph of really one of these equations, right? Because they're the same thing. So let's say, I guess you can say that we're looking for a point that lies on the uh, linear equation here, right? So that's the first thing, right? And the second thing is, well, if you're looking for a point that lies on that line, well, that probably means that point should trace that line throughout its path, right? And this is what I like to call the follow the point method, right? So let's look at the actual problem now, right? So here we have these four answer choices, all with r's in them, right? So what I'm going to do first is actually type each one of these into Desmos, and I'll show you why in a second. But let's type A, for example, right? So we have 3, I'm going to use R, right? Make sure you add the slider. So you have 3R plus 2, comma, 15R plus 11 over 7, right? And what you'll realize, right, because R is that constant that we can change, right? Remember, R can be any real number. Well, if you move the slider back and forth, right, what you'll realize is that it actually stays on that graph of 5x minus 7y equals -1, right? It never diverges from that path, right? This is what I mean by follow the point, right? The point here follows that line of the system, right? So what does this actually mean? Well, it means that for any real number r, this point always is going to lie on the line, right? It's always going to lie on the graph of 5x minus 7y, right? And therefore also the graph of the second equation, right? Because they're the same exact thing. So actually, our first answer choice here that we tested is the right answer, right? Because the point always stays on that line. Now let me show you another answer choice where it doesn't, right? So let's say you test answer choice B out, right? So you have 3r minus 2, comma 15r plus 11 divided by 7, right? Well, now look at this, right? Now if you move the slider, well, you'll realize that the point doesn't follow the line anymore, right? It's a bit offset. it's as if it's tracing another line instead of the one that's given in the problem, right? So this is exactly what I mean by follow the point, right? Answer choice A here follows that line, right? It follows the path of that line. And just as a way to check yourself, right? We got A as our answer here. Well, there is actually a way you can verify your answer, right? And how you do it is, well, right? Think of this as your X and this as your Y, right? So if you plug those in to this equation here, well, it should be correct, right? It should give you an equation that holds true. So let's do that. So you have 5 times x, which is 3r plus 2, minus 7 times y, which is 15r plus 11, divided by 7, and all of that equals negative 1. If you simplify, you get 15r plus 10, right? Minus 15r plus 11 equals negative 1. And of course, if you simplify this, the 15r's cancel out, so you're left with 10 minus 11, right, equals negative 1. Well, guess what? That is true, right? 10 minus 11 is negative 1, so negative 1 equals negative 1. And therefore, our equation holds. So yeah, first use Desmos, and you can plot these points and follow and determine if they follow that path of the line. And second, what you can do to check your answer, if you're really just want to double check and be confident about your answer choice, is just plug it back in to these equations here, right? And if they hold true, then you know you have the right answer. So hopefully that explanation made sense, right? If it didn't, well, please leave any comments you have down below. But for more, please hit the like button and click on that subscribe. We post videos here daily to help you with your SAT or ACT prep. So if you want to be notified when they come out, click on the notification bell. But I really hope you enjoyed this video, and I'll see you next time.